Hello and welcome to the floor. We're going to try to be restoring this Glory SR600 to its former glory. I haven't tried powering on or anything yet, so I'm sure it either absolutely works or doesn't work at all. But first we're going to do some maintenance on the case and get some things set up to test out with. First to note is we got to fix up the receipt part here. And then sadly I don't think there's anything we can do about the ribbon in it. Well, no idea what else to do before I power it on, so I might as well just power it on and see what it does. We're getting some loading thing on there. It seems unhappy. That might not be good. It beeped a little. Alright, this unit might be no good. And now it's clicking. Sounds like some sort of short in it. It doesn't really sound like something that I would expect it to be making. This will turn into a full teardown and not a restoration. Okay. So it's got a standard DB9 serial and also this awesome connector thing. Fancy. Alright, well, I guess we should start cracking into it. Cables come off, so we'll take those off first. I'm going to take off all these bottom screws and see what happens. That makes sense. We went from 5 pins to 16. That's designed for interesting stuff. Very interesting retention clips. There we go. That's why I thought it did something like that. It just kind of slide it over and it pops right out. Beefiest DB9 I've seen in a while. No idea if there's screws in the feet or not. Missing one screw there already. And one there. Probably for a board, but since that's free completely, so that screw will be obvious in a second. Well, I said free completely, but maybe I'm wrong. Ah, it is. It's very heavy. I think I would figure that out by carrying it a bunch. Well, how useful. Oh! Alright. It's very old school construction. 80s, I would say. Late 80s at the most. Because I would think... I don't think there's anything too spectacular or amazing that would imply this be an incredibly custom job, so this definitely has to be the construction of the time. You can see the individual key switches, so I might just harvest it for that if I can't get it working at all. Do not dispose of and fire. What is that? It's a nice battery. Alright. Well, I would vacuum this or something, but I'm going to just grab a can of dust and cover my mouth. Did I say can of dust? Can of air. Don't breathe this in, folks. Hey look, there's the beeper. Oh, it's smaller than the footprint they designed. Good enough for the most part. Very interesting dip switches here. Lots of single inline packages. Beefy. Oops. Well, that was the... Oh. That'll have to do. Classy. Look at that thing. That is beefy. You know, there's no... Well, I guess besides looking at the wires, there's no real way of knowing which part you could plug that into, since they left it that way. Power. Molex. This connector actually is the size of the one underneath it, so you can actually tell where it goes. Sorry about that box. It's quite broken. Wouldn't prove much resistance. This is going to come off, isn't it? This has seen better days. There's quite a noticeable bit of rust in this corner. There might be water damage, and that's why it's shorting. And that spring is really taut. Hello, this will be edited out. You know, it was more loose before I took those screws off. That amuses me. Is that near? There are 2 bridge rectifiers. Alright, well let's take a look at this power supply. The bleh way. Poor giant flare. Anyway, this camera's going to be vomit inducing, but it'll work for until I take the board out. Giant bridge rectifiers, awesome transformer. Here's a nice VFD. Oh, makes a lot of sense what this does now that I see it. It controls the printer. Cool. I want to take this VFD out, I think, and that'll help us work a little easier. Everything has really nice, like, retention washers and everything. Definitely get your money's worth out of this. Oh, I missed something. It's just stuck. Why is it stuck? It's kind of fused onto this bracket back here. It's not glued, is it? There we go. Ah. Oh, maybe the sticky back. Okay. Weird. Oh, here's the power for it. It's just, it looks really bad. I don't know. Free little board, be free. Now that I look on the date codes, we're looking at 90. 44th week of 90, 38 somewhere else 90. If I learned anything about these clips, it's that I should use screwdrivers more often. Now let's see if it was safe to touch. Should be good now. At the moment, I don't know if I care about the driver for the printer right now. And that's just a beefy, but probably not too high voltage transformer, unless there's some crazy thing for the VFD. Let's get the keyboard out, shall we? Every single screw has an impossible to shoot washer on it. It's as dirty as I'd expect a keyboard to be. Bleh, bleh. And look, and when we want to do the key, all we have to do is figure out which things to short together. It must have been nicer than actually locked. There can be two keys on here. I just now realized the bottom of this thing is metal. So let's go ahead and look at the main board on this. This seems to be the higher power side of it, designed for running the printer, as we saw this connector goes to. And then all of this is the processing on it mainly. So here's the HD64180ZP8, which is Zilog Z180 compatible, which is Z80 compatible, sort of, and it's running at the 6.144 megahertz. Notice the board has all kinds of these little tiny decouplers everywhere, and it seems to mostly be 7.4 series logic. Like here's one, here's one, here's one, here's one, another one, 7.4, 7.4. so on. So it's mostly using 7.4 series logic to do all kinds of different control like that. We've got 2 EEPROMs on it. This I definitely say is the firmware for the register because it's the SR600 register. And then JP600 is something else for it, I would assume. Tons of the old style resistor packs in the single inline package. And I love the detail they've gone to with almost everything that stands up has little spacer feet on it. Back on what I'm considering the high-powered side, we have a relay here, these large packs I need to check out, and then these are not any type of linear voltage regulators. They're actually large transistors. Fairly beefy 1 ohm resistors. I can't get anything out of that battery. Really nicely, they do have these cool little test points here and there for different spots that are just actual posts that you can clip something to, say your scope or whatever, which is very handy. So there's the, they've got 2 grounds. I'll show you that one in a second. So here's 1 ground. Here's a test point for the 5 volt. And if we go over this way, we've got a test point for the 24 volt. And over at the top is our other ground. I don't really see any other points anywhere unless they're hiding, but that's the only voltages you would expect on here anyway. I wouldn't expect there to be any 3 volts. These parts here, if they are both the same, are Senken STA401As, which are transistor arrays, bipolar junction transistors. It's 4 NPN Darlingtons, and they can handle quite a bit. You can actually still buy them, and they are $339 one-off price on DigiKey. Nice Omron relay. And this staggered leg part is a microcontroller. So you have on here a CPU and a micro as well. And then I'm going to look it up, but I would expect these to be some sort of I/O controller, but I'm probably wrong. Oh, Z80A SIOTD. So I think that is a Z80 support part. So this is some form of Z80 behavioral adapter. So this part is a high-speed programmable input-output interface. Has 24 programmable I/O ports. Over here is this wire that connects to the chassis and is just soldered across the assumed 3 ground points. The back, while incredibly dusty, but we won't worry about that, it's just very common kind of auto-traced, auto-routed, whatever, straight line construction on everything. There's no giant ground planes throughout most spots, so you can see straight through the board. And other than that, fairly boring on that side. So here's a style of dip switch I've never seen before. Kind of nice. And then instead of dip up here, it's just a bunch of those little shunts that you can put across to everything. Slightly less over on this side. So let's grab a different board. Here's the vacuum fluorescent display, and as expected, you typically make your own board, but then you buy the display pre-built, and those usually have entirely surface mount construction. So as we can see, it's probably an NEC display, since it's mostly NEC parts. Probably, once we get over here, we can see hidden under the tape is NEC. So that's definitely probably an NEC display. Get to the model number in a bit. Don't know what's in this thing here. So this is probably some form of transformer, which could be generating high voltages for the vacuum fluorescent display. I can assume that. Gotten a bit bendy. Here again is that dodgily placed clock. One little tiny 1 amp fuse. So I might try to mess with a parallel interface with this in a bit, maybe, since it actually isn't using a flat flex, so you can realistically plug into this. Could even breadboard that extremely easily, just putting. If you really had to and didn't want to make a custom solution, you could take some of this male-to-male connectors and sit here and boringly plug them all in, and then just go over to a breadboard. But that would be the silly way, because you could actually put connectors on a breadboard or something and jump over, or take this out and plug in connectors. Doesn't matter, but at least it's not flat flex. Here's the power supply for it. The taps off the transformer come in here. There's 2 quite large bridge rectifiers, as far as I can tell, unless I'm crazy, with nice stuff on the feet. 5 amp fuse. So there's the big beast, which we'll take a look at on. Anyone that's smart will know what that is without having to look up things. So it's a low dropout voltage dropper. So that one can give out 2 amps. So that seems to be 5 volt 2 amp. So on it we have this 25 volt 22,000 microfarad capacitor, and then over here is a 50 volt 6,800 microfarad capacitor. Here it is set up in pieces on the bench. I only have the transformer, the power supply, and the main board. I'm just going to check voltages on it and make sure everything is as expected. And I have to be extremely careful about the power supply end, and I have maintained ground everywhere. And since this is main earth referenced, we can't go poking around with the oscilloscope quite immediately. So I'm going to power this on kind of at a safe distance for a second and make sure nothing explodes. It's clicking at me. Five volts, 24 volts. Yeah, I would assume there is a problem somewhere because it is just clicking. That cap is ever so slowly draining. Well, there was a bit of a charge on the battery. The test points show it fine for power, so it's not some fault in the supply. Now, could it be a fault farther on? Probably. I'd have to look up a bunch of data sheets to really see which pins are power and to measure them accordingly. Well, we can very easily narrow down the problem. I've taken out the main EEPROM for the CPU side of things, and that seems to alleviate the problem it has. So let's show how it reacts to being turned on like this. So we'll turn it on without the EEPROM. The relay fires because the printer side of things loads, but nothing else happens. Still happily chirps when you turn it off. Now let's kind of seat the ROM in here. I'm not going to do an expert job, but I will make contact with everything. I can't do it from this angle. Now I can't say the ROM is bad, but we can definitely tell it's that side of things that's causing the issue. So you could kind of trace out that part and assume that it's nothing else. So let's show that. It just clicks, and if we look at the VFD, definitely a bit of an issue there. And I've, as I previously shown, I did go ahead and check the voltage rails, so they're fine there. You'd have to check closer. So really, at this point, it's basically shot until I dump the EEPROM and verify its data and determine that the problem is farther down the line than that. But for the moment, we could assume something's happened to the program. Worst case scenario, if I don't do a follow-up, I'll try to annotate, but if I don't do a follow-up of me having dumped that ROM with, say, an Arduino and checked everything, it'll then be a video of me scrapping this and making some very interesting projects with the extremely weird parts down here. Anyway, that was my look at this register. Sadly, it doesn't work, and I can't show you or do anything, but that also means that all of these parts are scrappable if I can't make it work. If you have any suggestions, please leave a comment.